Made a what? All right, give me questions about your homework. I'm scared to ask.
Okay. So I was confused on this question, and it just plugged in 6. Yeah, where did it get 6?
Which one are y'all on?
17.
Okay, wait, y'all have looked at the solutions. Is that what you did?
No, well, so I was doing it, and I was confused on the problem, so I checked the solution thing. Right. And they plugged in 6, like, they just got a 6 out of nowhere. Twice. It was 6 both times, like, why 6? I don't know what this is. Like 6 is like not a good number. It's like the devil number. If they did it 3 times,
It's the devil number.
it literally pulled it out of nowhere. I was so confused. I was already figured out that number. And then they pulled 6 out of thin air.
Are y'all sure on 17 is where they pulled a 6?
Yes. No, I'm not. And it's pretty sure it was. Yeah, I was able to do the second half of 17, but the first half, it made no sense.
Okay, well, let's do the difference question. Is that what I told you to do here? Left and right hand limits. So let's do the limit as x approaches 2 from the left. And skip a. I'm trying to think of why I told you to do the left and right hand limits here instead of the difference quotient. Are y'all sure? That's not this one they did.
No, it is.
All right, so I'm going to come off to the side. This is the left-hand side. So f of x plus h is going to be 1 over x plus h. Yes? And f, but this needs to be 2, right? Okay, hold on. From the left, so I have 1 over plus h minus 1 over 2, all divided by h. We need common denominators. What's your other point it brings up? Okay. I'm going to give this one a 2. I'm going to give this one a 2 plus h. Are we all in agreement here? Yes. All right, so now I have the limit as h goes to 0 from the left of 2 minus 2 plus h over 2 times 2 plus h. And I'm actually going to change this to 1 over h. Okay? Tell me if you disagree with something. Because it was in the bottom, and I got fractions and fractions. I'd rather just have one fraction if I can, rather than fractions and fractions. All right, so I got the limit is h goes to 0 from the left. This is going to go away. So I have negative h over 2h times 2 plus h I'm not gonna lie, I don't know where they got the 6 either. But here, if I plug 0 in now, I get negative 1, 4. Is that the answer they got? What did you do? Okay, well, we got to do the other side. You did the other side also? Let's do the right.
Wait, what did you do differently though? So I did this question here that after x plus every x plus that's what we are doing.
Yeah, I did it.
You have to plug in the x plus h also.
Yes, I did.
So you plug in whatever x it gives you for x.
Because it said at x equals 2. Because it said I rock at x equals 2. At the end, you plug in 0 for h. And normally, if this is a normal limit, I plug in h, I plug in 0, I try substitution here, but I can't because I'm dividing, I'd be dividing by 0. So that's the point of all the algebraic manipulation. That's why. So this is a derivative, and we will, but you are guaranteed questions that are going to ask you about the difference quotient because it is the definition of the derivative. So,
I don't like this one.
did they already show you the shortcut? Don't watch those yet. You're ruining the surprise. Everybody's always mad whenever you get to the shortcut. Why do I have to do all that? But you have to do it because there's so many limits questions that test your knowledge of the definite. Just like we test the definition of continuity with the limits and stuff, they'll test the definition of derivative with the difference quotient. Well, for right now, they'll ask for the slope of the tan line, and the only way you should know to find it right now is this way. All right, this is the limit as h approaches 0 from the right. This time I'm using the other equation, yes? All right, I'm still 2. F of 2 over h. This time, f of 2 plus h is 4 minus 2 plus h over 4.
Let's just do it again.
You're good there? Here from the right of gross. When my head's not so stopped up, I'm going to go back and figure out why they got that 6 from. Again, I'm going to go ahead and do 1 over h here. Makes my life a little easier.
Okay.
This one's this one. Yeah. Instead of dividing everything by h, I'm just making it a little easier for me to work with.
We always do that for the fraction.
I would, if you end up with fractions like that. 0 from the right. What is this? 2 minus h over 4 minus, I'm going to make that 2 over 4. Right? Was that too much for y'all at one time?
Yeah, so 4.
Okay. Any common denominators?
Yeah. What?
That's that dividing by h I had in the beginning. I just switched it to a reciprocal multiply. Which 4? 4 minus 2 is 2, and then the negative distributed through to the h. Right, because this 4 minus 2 plus h is the same thing as 4 minus 2 minus h, which would be 2 minus h.
Well, why did you do the common denominator?
Because now that these are common, I can do that.
Now you can cancel these two.
Now the 2's can.
And you've got negative h over 4. But yeah, that should be negative h over 4.
Negative h over 4h. The limit of a constant is the constant itself.
Negative 1/4. That's it.
So I get it the same from the left and the right.
That wasn't even all that bad. Like,
No.
what's the thing with the 6?
I don't know. I'm gonna go back and look at it. I'll figure it out.
So negative 1/4 is a foot, right?
Yes, the slope became
But
on
it
at 2.
wouldn't be though if it was different side. Like,
Right. You need it to be the same from both
so
sides.
what if
Here.
I told you to find the slope and it was different on each side?
You would say that it doesn't exist.
Okay.
So I think 15. The slope from the left was negative 2. The slope from the right was positive 2. So the two-sided limit of the difference quotient doesn't exist.
Okay.
Yeah. No, what were you saying about your h?
I canceled my h's early, so I ended up getting 1/2 times the negative 1/2, which is negative 4. But I canceled my h's on the up there. I don't know why I did.
He marked them out. No, just kidding. Go ahead.
I did half plus h minus a half over h. And then
You did a half plus h over h.
yes,
You killed a kitten.
I didn't say that. No, I did that minus f minus half. Oh, I did that minus half.
That?
So f was, yes, I did that, and then I got, so yeah, I must have it.
Yeah. If you canceled an h there, you killed a kitten.
Yeah, I did that. Oh, wait, no, yeah, that was maybe that. So I canceled those two, and then.
But I was gonna say, even if you canceled them, then you'd get 0.
Yeah.
Yeah. And you might have seen that the answer was supposed to be negative 1/4 because the answers are in bold blue beside the problem and went, oh, of course 1/2 times negative 1/2 is negative 1/4. I got it. Yeah. Absolute value as in what? Okay, so find the slope of the curve at the indicated point. Okay, well, let's do it. 13. Just B? Okay. So we have f of x equals the absolute value of x. And it looks like this is a grayer calculator or non-calculator? Non-calculator. So this is a calculator. That's probably going to be important. You didn't or you did? Huh? All right, so the slope at the point, so I'm IROC. So I'm going to do the limit as h goes to 0 of x plus h minus f of x over h, but my x is negative 3. All right, so f of negative 3 plus h would be well, but you can't.
I mean, I know it's like
You
two
can't
equations.
split it up like that.
Well, what if you split it up into two absolute values times 10? So absolute value is negative 3 plus absolute.
That's what I'm saying. You can't split that up because think about if h was 5 and you plug that in there, you'd get 2, right?
Yeah.
But what if you had split it up and you put in 5? Well, then you would get 8 instead of 2. So that doesn't work.
Right, so that can be.
Well, let's work through and see what happens. Let's work through and see what happens. F of negative 3 is just going to be 3. So the limit as h goes to is negative 3 plus h minus 3 over h. Right? I would say, since this is a calculator problem, I would graph this. What does that look like on a graph?
Absolute value is going to look like this.
Right. All right, what's my equation again?
It's negative 3. Well, absolute value negative 3 plus 8.
All right. Absolute value. Where's, oh, it's over here. Absolute value of x.
Well, x minus 3, that'd be the same thing. And then minus 3 after the absolute value minus 3 over 8.
How much should I have? Over what? 3? Over h. X. So it's undefined at 0, right? But I can do the limit. The left-hand limit and the right-hand limit is the same, so the limit exists there, even though the point's not defined. What's the limit?
Well, the limit will be negative 2. Right?
It is. What's it coming to?
0.
Negative 1 from both sides. The limit as x approaches 0. Because I'm trying to make h be 0. They did one positive and one negative type situation. Well, because when you're in absolute value, if h is negative, it's going to flip it back over to positive anyway. You see what I'm saying? Are you talking about the way they did it algebraically? Okay.
So what would you do then, like, wait, what's it asking for the question?
Which number is this? 13? The limit, the slope of the tan line at that point.
Well, the limit doesn't give you the slope, though, right? So that we wouldn't have no slope yet. Also, doesn't a tan line have to go through something?
Like, how does the h look negative?
So here's why that works. If you have the absolute value of x, that means this could be x or negative x and you get the same answer. So inside these absolute values, this could be negative 3 plus h, or it could be positive 3 minus h. And you'd get the same answer as well, because what you're doing is you're making it negative because it's going to flip it back to positive anyway. So what they were saying here is, because here, if I leave it like this, negative 3 plus h minus 3 over h, nothing cancels, I can't solve it, right? But if you take the negatives, no, that'd be negative 6.
No, change it around.
But if you change it around, so you get 3 minus h minus 3 over h, you'd end up with negative h over h. It's just one of those algebraic properties of absolute values that will let you, so anytime you see an absolute value, you can set it equal to the positive of the inside or the negative. Do y'all remember solving those before? And if you have something like x plus 2 equals 5, you do, and you solve it that way. Y'all never did that in Algebra 1? Okay, if you have an absolute value, the definition of absolute value is that it can be positive or negative and it spits the same thing back out, right? So if I set it, if I just drop the absolute values and solve, that'll give me one answer. But if what's inside here gives me negative 5, it's still going to spit out a positive 5. So I have to take that into account. So I'll also set it equal to negative 5. So this is the same concept. Take what's...
What is absolute value?
Absolute value makes anything inside the absolute value positive.
All you need is
So
that.
how would it be negative? That's like,
Okay, so this would be you'd subtract 2, right, and get negative 7. What is this if you plug negative 7 in for x here? So you've got absolute value of x plus 2 equals 5. If you plug negative 7 in there, what do you get? You get negative 5. What's the absolute value of negative 5? 5. So this is a solution. It works whenever I plug it back in. Because if everything in here changes,
Can you subtract from, like you took the 3 from the outside of the absolute value and subtracted it from the one that was inside the absolute value?
okay, so yes, and if it works that way, if it works to where you can drop the absolute values and simplify, you can do it that way. Because that's one of the
If
solutions.
the absolute value is so positive, like you'll still be around the 8.
No, you can't split them up that way. You can't split them up. Let me say this. This, if you have the absolute value of x minus 7, okay, this could be x minus 7, or this could be negative x plus 7. You can look at both scenarios to see which one helps you solve. Either one of those scenarios will work. Think about the absolute value graph, right? The positive side will work or the negative side will work.
I was trying to figure out how you do the 3
Well, you drop the absolute value for one and you negate everything for the other. Does that make sense? A little bit? No.
Drop an absolute value there.
You can for one scenario, but then for the other. Did 14 work out the same way? Was it a sticky? Let's look at it. This says at x equals 1. Okay? So the limit as h goes to 0, right, of f of x plus h minus f of x over h. But this is 1. Right? So f of 1 plus h is going to be 1 plus h minus 2, which is going to be negative 1 plus h. Are you okay there? And f of 1 is going to be yes? So this becomes the limit as h goes to 0 of, what do I have, negative 1 plus h minus 1 over h. So this sets me up for two scenarios. Negative 1 plus h minus 1 over h, or 1 minus h minus 1 over h. Which one is going to help me find the solution? The second one. So I'm going to ignore this one for now. I'm going to use this one, right? Well, because over here, negative 1 and negative 1 is negative 2. Nothing cancels. I still can't plug 0 in. Should be negative 1. Well, the h is canceled. See, h was in the denominator and it didn't work, so I simplified it.
But really though, when it's asking you to find a split, like you just plug that whole equation in your calculator and find like the top equation, the negative 1, absolute value negative 1, that's like
Here, yes. If it's a calculator problem, you can. But you need to show that you understand the difference quotient. If this is a calculator like an FRQ.
Well, you would have to get that.
Right. Right. But what I'm saying is you need to show this written down. Even if you're plugged in your calculator, you need to show this written
I'm
down.
trying to find ways that I can get faster.
Right.
I was doing tomorrow, I'm not going to have time.
I bet you will. All right, what else? It's already posted. The review.
Oh, this week I found out only because of you that I got one of these math questions right on the SAT. So I have no clue.
Were you not in here when we were talking about this? You talking about the square root of 2 over 2 one?
Yeah. Well, that wasn't even what helped me. I kind of did. I had no clue what it was, and I saw pi over 12. It was like n pi over 12. Like the only one was pi over 12 is 7. That must be the answer.
What's there? Alright, so again, we're going to do difference quotients from both sides. So we'll do 3 pi over 4 from the left, and we'll do 3 pi. No. Y'all not even stopping me. We're going to do 0 from the left and 0 from the right because we're difference quotient here. There we go. You like this one? They're nice when they work out nice. Yeah. 3 pi over 4, anything over 4 is always nice because the only thing you have to think about for those is which quadrant you're in. Am I going to be positive or negative? So which quadrant is 3 pi over 4 in? Second quadrant. No. So the second quadrant means that cosine is negative, but sine is positive. Yes?
Yes.
Because I'm left and up. All right. So I have f of x plus h minus. I know I write this a lot, but it will help you if you continue to write it because then you won't forget it because you'll write it so much. All right, x.
I just think so on the right.
Oh my goodness, what? X is 3 pi over 4. So over here on the left side, f of 3 pi over 4 plus h is the sine What's the sine of 3 pi over 4? Square root 2 over 2. Not sine.
Cosine.
Limit. As h goes to 0 of the sine I need to make sure both are the same. Yeah. It told me X. That's okay. It is. What shall I do? How are you going to solve that?
Wait,
Why would you not use the cosine, please?
I think
Somebody that's zero. Someone explain.
oh my god. This is tricky because I guess it is exciting, you know,
Well, dy equals mx plus b, and then do a little bit of point slope with some quadratic formula.
Let's think about this graphically for just a second.
All right.
Sine from 0, here's pi over 2, pi. All right, so my cutoff's going to be somewhere in here. What does sine look like? Sine of 0 is what? The sine of 0?
0, 1. 1, 0. 0, 0.
It's 0.
1, 0. The other side is at the top is 0.
This is sine. cosine.
Yeah, that's
What is happening at this point?
um,
If that's where it's cut off, right? This keeps going like this. So it's saying that sine is stopping here. Okay? And that's where cosine is picking up and then going from here. So this graph looks something like it's a weird graph, right? But what's happening at the point that we're looking at? It's a jump discontinuity, right? The graph is not continuous there. The limits are nowhere close to each other. The left-hand limit and the right-hand limit are nowhere close to each other on those.
but no, so we don't have to do this.
So because it's discontinuous, the difference quotient isn't going to exist there because it's not going to be the same for both of them.
So there's no.
They got -1.
For 18, they better not have.
Yeah, they got -1 for.
No, the function is discontinuous because
What was I looking at?
I don't know. Because here, okay, so the blue is sine, right? And from 0 here, and then this sign didn't have a line under it. So it told me to stop right here, but don't include that point.
All right, I wouldn't have been able to graph that. So how could I do it without graphing that?
Okay, well, what is the sine of 3 pi over 4? What is the cosine of 3 pi over 4? No. No, they're not. Negative square root of 2. They're not the same. It jumps from here to here.
We're in the second quadrant.
Because this inequality told me to take this graph between 0 and 3 pi over 4. So look at your unit circle. 3 pi over 4 comes right before you get to pi over here, right? Here's pi. 3 pi over 4 comes before you get to pi. Stop there.
Well, no, it's Andrew's side go for it.
What did you mean by stop there, though? What is it?
It's a piecewise function, which means this is going to go, if you want to look at it as like a plug-in method, this goes from 0, which is 0, to 3 pi over 4, which we said was square root of 2 over 2. So this point right here is 3 pi over 4, square root of 2 over 2. Okay?
And then the cosine.
And then the cosine at 3 pi over 4. So this is 3 pi over 4 negative square root of 2 over 2. And then the cosine graph continues until I get to 2 pi, which happens here. Because it goes up. So I don't need any of this. That's not part of it. These as in what?
Like radius.
We know.
It's not going to be overloaded with these, but it'll be enough to test to make sure you understand everything.
Well, how many does that mean? We just gotta tell us.
I honestly, well, to be honest, I haven't made it yet. I'm making it today. I have an extra planning today.
Dude,
to
I
work on.
want to take it on Tuesday.
Do I?
I'm not gonna like it's gonna be a long break out of stress.
I would say possibly a Pythagorean identity, but nothing past that. That's cosine squared plus sine squared equals 1. Sine squared plus cosine squared equals 1. It's a mixture. There are some multiple choice and there are some free response. Yes, but no, you're not. No, you're not. Give me more questions about your homework.
You only got to make a 50 to pass. Only got to make a 50.
20?
I'll take one then. Yeah. Only
Yeah, if you want to start on the review, go ahead. It's fine.
only got to make
All right, 20 says describe what happens to the curve. No. Find the slope of the curve at A and describe what happens. This is typical calculus type stuff. Let me throw a variable in there so you can generalize what's behind. Bless you. And decide what happens. So what happens? It's asking me slope of the curve at x equals A. So slope of the curve right? But my x is A. All right, f of A plus h is 2 over A plus h. F of A is obviously 2 over A. So I have, and again, I'm going to change this to multiplying by 1 over h instead of dividing by h. So 2 over A plus h minus 2 over A. And I'm going to go ahead and start working with this to combine it. Yes. Where did I lose you? All right, so it tells me to use A for my x. Okay. This is f of A plus h. Right?
How do you do to plug H in as well? You plug in each section. So you plug in the A plus H, then you're going to plug in the
Basically, you just pull H out instead of one.
Yes. You can always do that.
Usually it'll be a number. So does that mean that you're multiplying the top stuff by 1 and the bottom stuff by H?
Yes.
That's how it is. All right, now what?
I need a common denominator, right?
Why do you do that? Because it's subtracting.
I'm subtracting. I need a common denominator to subtract.
So would it be H squared plus 2? Or actually, it'd be H squared plus
2A.
So are you just
Well, kind of. I'm multiplying to find the LCD. I essentially just multiplied these two together. So my denominator, my common denominator here is this. Conveniently enough, I do.
multiply over and multiply over right. So it would be like A squared times A squared plus A something.
I just left it multiplied together.
I know, but like at the top. Oh, wait, that's just your denominator.
Yeah.
Okay. That makes a lot more sense.
2 A's are gone. So now I have negative 2h over. This looks a lot like that one we did earlier. So the question asks, because now if you look, is h goes to 0, there's no h in here anymore. Oh, yes there is, I lied.
Well, you could probably still do that.
So if I put a 0 in, right, I end up with negative 2 over a squared. So the question says the slope of the curve at a, right?
A is negative 0.
So this, I hope this is what they got. I don't even see this one on here. All right, so the slope of the curve here is negative 2 over a squared. Okay. What happens as a changes? As a gets bigger, what happens to the slope? It gets closer to 0. So what's happening to that graph as you get closer, as a gets bigger and bigger? If the slope is starting to become 0, it's starting to become more what? Flat, more horizontal, right? Because a squared is in the bottom of the denominator. So as a gets bigger and bigger, 2 over a squared gets smaller and smaller and smaller. So it's getting closer to 0. You do, so because it says find the slope of the curve at A. So here's the slope at A. Yes, because that's always going to be negative because of the negative, because you're squaring in the bottom. That's going to ensure always positive. So you got a negative divided by positive. So your slope is always going to be negative.
You didn't write the negative.
Oh, sorry. So yes, I would describe that. And then it says, what happens to the tangent as A changes? As A gets bigger, that slope gets closer and closer to 0. So the graph is flattening out there. No, definitely not. This would be a definitely.
First test now, that first little quiz. I think I have the IROC now.
That helps me. That helps me.
We should try and do some problems on the board. We should try and do problems on the board.
Just quickly, 23 through 26, you had a couple of those here and there, but those are the exact same things. It's still your difference quotient. I hope you saw the pattern here. The difference quotient, difference quotient, difference quotient, difference. Yes. Yes, 33 is a great one. Another typical. So this one says, at what point is the tangent horizontal? And so the tangent is going to be horizontal when what? When, you agree with that? Horizontal lines have a 0 slope. So the tan line will be horizontal when the slope is 0. So how do, right, that's exactly right. So I'm going to do the limit as h approaches 0. F of x plus h minus f of x all over h. This is going to be a nasty one. Because here, Ollie, I think this is what you were talking about, where you get confused about this going in here, right? Because it's got to go in here twice. So f of x plus h is x plus h squared plus 4 times x plus h minus 1.
Well, the problem that I struggle with is knowing why the h has to go to x.
That's the formula. That is your, so this is your slope formula, but the difference is the h is, the instead of saying the difference in y over the difference in x, we take x and we say, let h be how much space is between my first x and my second x. And so it has to stay in there. If you FOIL it out, yeah, you do it. X plus h, x plus h, x squared plus xh plus xh plus h. When you're foiling, it's always the square of this. Put them together and double it. The square of that. You don't have to actually FOIL it if it's a square.
I always just square both terms, forget through the x or whatever,
Right. So this is x squared. Does this even simplify any? No, it doesn't.
Yeah, you need it. Yeah, over h, by h. So then you take out some h, right?
What?
It needs to be over h.
Well, this is only this. So now it's h goes to 0 of, so it's x squared plus 2xh plus h squared 4x plus 4h minus 1 minus f of x. X squared plus 4x This cancels. This cancels. And this cancels. So what I'm left with is 2xh plus h squared plus 4h over h. Because I took an h out of everything. As long as I do it out of every single one of them. I took an h here, I took an h here, here, and here. So remember, it's as h goes to 0. And what did I want to know? If I plug in now, I get 2x plus 4. I want to know, when does that equal 0? I don't know the x because that's what I want to find is what the x would be. -2. So when x is -2, I have a horizontal tangent. Subtract 4 and divide by 2.
And either way, you're going to be variables in the end.
Right. Y'all understood that one better than the others? Holy cow, that one was terrible.
I understood that way better than the I one. Yeah. Way better.
This one was way more conceptual with
That
the
one was just
variables.
canceling out H's. Like, once you get it plugged in,
All right, so we're out of here at what, 9:55? So I want y'all to get together and work through your review. At least pieces of until